Welcome to this explainer. Look, if you've ever tried to learn artificial intelligence and found yourself immediately just smashing into a brick wall of dense calculus, complex proofs, and overly simplistic toy code, I really want to start by validating your frustration. You are absolutely not alone in that. There is this massive disconnect in how machine learning is typically taught versus how it's actually practiced in the real world. So today, we're going to explore a definitive guide that bridges this exact gap. 30 must-know AI algorithms explained.
It's a question almost every single data professional asks at some point, right? Why is it that the leap from learning academic theories to actually writing production-ready AI code always feels like falling into a massive implementation gap? You read a chapter on an algorithm, you understand the general idea, but then you sit down at your keyboard to solve a real business problem and nothing. You realize you're completely missing that connective tissue that turns a neat concept into working, reliable software.
And that happens because traditional academic textbooks and production environments are basically two entirely different worlds. Textbooks are built on heavy math, theoretical proofs, and perfectly clean, tiny little toy datasets. But production reality? That is a completely different beast. Out in the wild, you're dealing with messy, unscaled data. You're wrestling with complex hyperparameter tuning, scaling issues, and models that don't just politely throw errors, they fail silently. Academic resources teach you that algorithms exist, but they rarely actually teach you how to engineer them for production.
Section 1. Meet your expert guides. To cross a gap this big, you really need guides who have navigated both sides of the divide. And the formidable combined credentials of these authors are exactly why this material is so incredibly practical. First, you have Sanjay Gupta, bringing over a quarter-century of hardcore software engineering and system design experience. And right beside him is Fangxu Xing, an assistant professor at Harvard Medical School with over 15 years of deep AI, computer vision, and biomedical research under his belt. Together, they bring this perfect balance, right? Harvard-level research rigor combined with decades of battle-tested software engineering.
And I absolutely love their pedagogical philosophy here. They explicitly state, you do not need a PhD, a background in mathematics research, or years of experience in the field. What you need is curiosity. It's so empowering. If you have intermediate Python skills and just a basic intuition for math, this guide empowers you to master these tools. It is built from the ground up for developers, data scientists, and engineers who want implementation-ready knowledge, not just abstract theory.
Section 2. The triple-level approach.
Okay, so to effectively teach these concepts, the authors did something really smart. They completely abandoned the purely academic format for a methodology that actually mirrors how engineers work. They call it the triple-level approach. Every single one of the 30 canonical algorithms covered is explained at 3 levels simultaneously. First, you get the conceptual foundation, the actual intuition of why the algorithm works. Second, you get the production best practices. That's the engineering wisdom that separates a fragile toy script from production quality code. And third, you get complete, runnable Python code demonstrating the algorithm on a concrete problem. It seamlessly takes you from concept right through engineering directly to execution.
And what's really cool is that before you even touch a line of code, the authors intuitively map out the entire AI universe for you. In Chapter 0, they organize the whole landscape into 5 learning paradigms: supervised, unsupervised, reinforcement, deep learning, and advanced techniques. This gives you a really clear mental map of the territory. It ensures that whether you're looking at a basic decision tree or a complex transformer, you know exactly where it fits into the broader ecosystem.
To make that map super easy to navigate, every single chapter reliably uses this identical 7-part structure. You never have to hunt for the information you need. You always get the definition, how it works, where it's used, best practices, Python code, common mistakes, and keynotes. So if you're an experienced practitioner who just needs a quick refresher on, say, hyperparameters, you know exactly where to look every single time. It literally transforms a standard textbook into an indispensable desk reference.
Section 3. Avoiding costly production mistakes.
Now this builds into what might be the single most valuable part of this explainer, and honestly, the book itself for working practitioners. It's all about navigating the trapdoors and pitfalls of real-world implementation. The authors emphasize a really vital truth here. Understanding how a model fails is at least as important as understanding how it succeeds. Think about it. In production, a data scientist's worst nightmare isn't a model that throws a loud error and crashes. No, it's a model that runs perfectly, spits out predictions, but fails silently because of some subtle algorithmic misunderstanding on the back end.
This guide specifically arms you against those catastrophic, invisible errors.
For instance, it points out that forgetting to normalize your features in k-nearest neighbors means a feature with a larger numerical range is going to completely dominate your distance calculations. It warns you against ignoring multicollinearity and regression, which makes your coefficients wildly unstable. And it even tells you that tuning XGBoost hyperparameters in the wrong order, like say tuning your regularization before your learning rate, is just a massive waste of time. This is that hard-won, pragmatic engineering wisdom you usually only learn the hard way.
Section 4. Your practical AI toolkit. So the goal here isn't just to give you something to read once and then shove on a bookshelf. It's to provide a permanent, highly practical reference guide that lives on your desk and actively speeds up your workflow. Take the algorithm selection guide flowchart, for example. It is brilliant. It shows how quickly a practitioner can navigate from a raw problem statement directly to the correct algorithmic starting point. Do you have labeled data? Yes. Is it a category or a number? Category. What kind of data is it? Tabular. Boom. You are immediately directed toward gradient boosting, XGBoost, or random forest. It just completely cuts through the analysis paralysis.
Beyond that flowchart, the companion resources basically guarantee a frustration-free experience. The book comes with downloadable Jupyter notebooks for every single implementation. And even better, and this is a big one, the authors explicitly pin the library versions. We're talking Python 3.8, NumPy 1.24, scikit-learn 1.2, and XGBoost 1.7. Anyone who has ever spent hours trapped in dependency hell trying to get some 2-year-old tutorial to run will immediately recognize how absolutely vital this is for guaranteed reproducibility.
Well, we arrive at the ultimate question. Are you ready to stop just reading about artificial intelligence and start actually building it? By combining conceptual intuition with production best practices in runnable code, 30 must-know AI algorithms explained offers a clear, highly structured path from theory to real-world mastery. So the real question is, in an industry moving this insanely fast, can you afford to keep letting your models fail silently? Grab the guide, fire up those notebooks, and finally cross that implementation gap. Thanks so much for joining me for this explainer.